But just use that section that shows Diane Carr, who's 5.75 feet tall. X, of course, is her shadow. We know this is a right angle, and this is 23.4 degrees. Therefore, to find x in this, we can use the fact that the tangent of 23.4 degrees is equal to the side opposite, 5.75, divided by x. So, tangent of 23.4 degrees equals 5.75 over x. Therefore, x is equal to 5.75 divided by the tangent of 23.4 degrees. Let's go to the calculator and plug in those values and calculate the length of her shadow. So I would want to plug in then 5.75 and divide that by the tangent of 23.4. Hit enter and we'll find that her shadow is approximately 13 3/10 feet. Other applications of right triangles involve bearing, an important idea in navigation. One method for expressing bearing starts with a north-south line and uses an acute angle to show the direction either east or west of this line. In the example on the left, we have north 42 degrees east. So we start on the north line and we rotate 42 degrees towards the easterly direction. In the second example on the right, we have south 31 degrees east. So this time we start on the southern line and we move 31 degrees towards the east. In my next example, I have south 40 degrees west, and that's on the left-hand side, and on the right-hand side, I have north 52 degrees west. Let's do an exercise using this method of bearing. We have a ship leaving port and sailing on a bearing of north 28 degrees, 10 minutes east. Another ship leaves the same port at the same time and sails on a bearing of south 61 degrees, 50 minutes east. If the first ship sails at 24 miles per hour and the second at 28 miles per hour, find the distance x between the two ships after 4 hours. First, let's find the angle between the two ships' paths. So in the diagram, we see that the three angles, including the angle between the ship, which I'm labeling with this red arc, we know that all three angles, which I now label the other two with the red arc, must add up to 180 degrees because they form this total angle right here. Well, we already have two of them, so basically what I want to do is take 180 and then subtract from that the sum of the other two angles, 28 degrees, 10 minutes, and plus the 61 degrees, 50 minutes. Now, interestingly enough, if you are familiar with the degree and minute and possibly, but not in this case, second measure, you could just add those angles as is. The other way would be to convert them to decimals on your calculator and then have the calculator do it. However, looking ahead in this problem, I know, because I've worked it out, that those angles actually add up to 90 degrees. And I want to show you that using the degree and minute version of it. So let's go back to the diagram, and I'll show you that if I add 10 minutes plus 50 minutes, that's 60 minutes. And 60 minutes makes a full degree. So what I would have is 28 plus 61 plus 1 degree, which adds up to 90. and therefore what I find is that the angle between the two ships is 180 minus 90, or in other words 90 degrees. So therefore this angle in here is a right angle, and I therefore am dealing with a right triangle. So now what I'm going to do is move to the board where I will draw essentially this diagram as a right triangle and then fill in some more information. So what I have is the two ships. This is a right angle here. And what I know is that this ship is traveling at 24 miles per hour for 4 hours, or in other words, it travels 96 miles. Now, the second ship also travels for 4 hours, but it's traveling at 28 miles per hour, so that means 28 times 4 for 112 miles. What we're interested in is this distance right here, which I will label x. In order to find that x, let me first find angle theta, the angle up in here. What I use is the tangent function to say tangent of theta is equal to the side opposite theta over the side adjacent to theta. So now I know that to find theta, theta is the inverse tan of 112 divided by 96. So let's jump onto the calculator, plug in inverse tan of 112 over 96 to find theta. So we have inverse tan. You have to push second tan, and that gives me the tan inverse function. Then I plug in the 112 divided by 96, close the parentheses, hit enter, and I see that my angle is approximately 49.3988, for example. All right, well, now that I have that angle, I can use either the sine or cosine function to find the hypotenuse. So let me show you that. This angle theta turned out to be 49 point, let me look on that calculator again, 0.3988. So therefore, the sine of that angle is equal to the side opposite, 112, over the hypotenuse, which I've labeled as x, which means x is equal to 112 divided by the sine of 49.3988. All right, let's move to the calculator, and we can solve for x, the distance between the two ships. So what's good about the calculator is I still have the 49.3987 in there. So what I'm going to do is say that I want 112 divided by the sine, and then I can plug in second answer function. So second answer, close the parentheses, and it's going to plug in my 49.3987, etc., and hit return, and it comes up to 147.51. In other words, we could basically just round that off and call it 148 miles that the two ships are apart.